Right. Buckle up, everyone. Today we're going to be taking a deep dive into Clean Architecture by Robert C. Martin.
Yes.
Akawai, Uncle Bob.
Uncle Bob, that's right.
You sent this book over, and I have to admit, just the title alone, it makes me think like spring cleaning for code.
Right.
Is that, am I close?
That's a fun way to think about it, yeah. I mean, it's less about like dusting and more about building a house that can withstand change, grow, and stay awesome even as, years go by.
Okay, I'm intrigued. But before we get all hammer and nails with it, can you give us the quick pitch?
Sure.
Why is this book a must-read for anyone who writes code, builds software?
Uncle Bob's argument is that most software over time gets harder and harder to work with. And it's like trying to cram a bunch of mismatched furniture into a tiny room.
Yeah.
You know what I mean? And this book gives you the blueprint for building software that's easy to change and adapt, which honestly is more important than it working perfectly right now.
Whoa, hold on.
Yeah.
You're saying it's better if my code isn't perfect right now.
Yeah.
Explain that one.
So think about it. What happens when your needs change? And you need to update that perfect code.
Right.
It can become a nightmare. But if it's designed to be adaptable, those changes are smooth sailing.
Okay. Point taken.
Yeah.
Adaptability over initial perfection. But before we go any further,
I
have to mention this dedication to my grandchildren, the dessert of my life.
I know, right?
Now, that is how you write a dedication.
I know.
Right.
Even the toughest tech folks have soft spots.
Yeah.
And speaking of seasoned, Uncle Bob's been coding since 1970.
Wow.
So he's seen it all. This isn't some fly-by-night theory. This is wisdom earned through decades of building software.
So he's not just telling us what to do, but why.
That's right.
These ideas matter based on his own battles.
Exactly.
With messy code. I like it. One thing that confused me, though, is this whole, design versus architecture thing.
Right.
Is there even a difference?
So it's a point of debate.
Okay.
But Uncle Bob says they're basically the same in software. It's like arguing over interior design versus house blueprints.
Okay.
Ultimately, they both shape how well the house functions for the people living in it.
Okay.
Yeah.
So it's not about the labels, but how these decisions
Exactly.
impact the software's long-term
health, yeah.
health, right.
Exactly. And that health is directly tied to the software's shape.
Okay.
Remember that crammed furniture analogy?
Right.
As the code base gets messier, adding new features becomes a struggle.
Like trying to squeeze one more suitcase into an already overstuffed car trunk.
That's a good one, yeah.
But I feel like we jumped right into the deep end here.
Okay.
Didn't Uncle Bob talk about the history of programming to kind of set the stage for this whole clean architecture idea?
He did. He starts way back with Alan Turing, the guy who basically invented the computer.
Yeah.
Now, here's the mind-blowing part. Back in the 1930s, Turing realized that programs could be treated as data. It's like realizing you can use the same Lego blocks to build a spaceship, a castle, or even a robot.
Wait, so that programs as data idea is why we can have apps for everything these days.
It laid the foundation
That's wild.
for the flexibility and power of modern software. But the early days of programming were rough. Imagine trying to write code without any clear rules or structure.
Yeah.
That's where Edgar Dijkstra comes in.
Okay, I've heard of Dijkstra.
Yeah.
But honestly, all I know is that his name sounds like a complicated algorithm.
Right.
What did he do that was so important?
He was a huge proponent of structured programming, which is like creating a clear recipe for your code.
Okay.
He hated something called go-to statements, which basically made code jump all over the place. A recipe for disaster.
Yeah, I can see how that would be a problem.
Big time.
So Dijkstra brought order to the chaos
He did.
of early programming.
Yeah.
Did his ideas lead directly to this clean architecture thing?
Not directly, but they were a stepping stone. He even tried to mathematically prove that code was correct, but real-world software is just too complex for that.
Yeah.
His work led to the rise of object-oriented programming, or OOP.
Okay, OOP. I know that's a big deal.
Yes.
But I sometimes get lost in the jargon.
Right.
Can you explain it like I'm, well, not 5.
Sure.
But maybe a curious teenager who's just starting to code.
Think of it like building with Lego sets again.
Yeah.
In the old days, you just had a jumbled pile of bricks.
Right.
And building something new meant taking apart what you already had.
Yeah.
OOP gives you these neat little modules, objects, with clear instructions. You can snap them together,
Okay.
reuse them, and create much more complex structures without breaking everything.
Okay, that clicks.
Yeah,
So OOP brought more organization to software development.
it did.
But didn't Uncle Bob also talk about functional programming?
He did.
How does that fit in?
So functional programming is like a different style of Lego building. Instead of snapping things together and changing them constantly, you focus on creating these unchangeable blocks,
Oh, okay.
immutable data,
Yeah.
and use functions to transform them to get what you need.
I'm trying to picture that. Give me an example.
Okay, so imagine calculating the square of a number.
Yeah.
In a typical language like Java, you might change the value of a variable as you go.
Okay.
In a functional language like Clojure, the data stays the same, you just apply functions to it,
Right.
multiply this number by itself.
Okay, I see how that could lead to cleaner,
Exactly.
more predictable code.
It's more declarative.
So we've got this history of programming paradigms, but how do we actually get to clean architecture?
Right.
Where do those solid principles that everyone talks about come in?
Those are our building codes for clean software.
Okay.
They're not just rules, but guidelines to help us avoid common pitfalls that make code messy and hard to change.
All right.
Let's start with the single responsibility principle,
Okay.
or SRP.
All right, SRP. Hit me with it. What's the big idea?
Imagine a Swiss Army knife.
Okay.
It's got a blade, a screwdriver, scissors, all in one.
Right.
Sounds great, right?
Yeah.
But what happens when one part breaks? The whole thing becomes useless.
Ouch, yeah.
So SRP is about each piece of code having one job and doing it well.
So it keeps things focused.
It does.
Makes your code easier to understand, easier to change.
Exactly.
Okay.
Then we've got the open-closed principle,
Okay.
or OCP. This one sounds tricky.
Yeah.
How can something be both open and closed?
Right. It's like saying a door is both open and shut.
So it's about designing systems that are open to extension but closed to modification.
Okay.
You want to be able to add new functionality without changing existing code. Kind of like adding new apps to your phone without messing with its operating system.
Okay, so it's more about strategic design than literal open and closed.
Exactly.
What about the Liskov substitution principle? LSP. I've stumbled over that one before.
LSP is about making sure your code behaves predictably when you use inheritance.
Okay.
Let's say you have code that assumes all birds can fly.
Yeah.
Then you create a penguin object.
Right.
Suddenly, your code crashes because penguins can't fly.
That's a problem.
So LSP is like a safety net to make sure those hierarchical relationships in code actually make sense.
Okay, got it.
Next is the interface segregation principle, or ISP.
ISP.
This one's about keeping interfaces focused.
Yeah,
You wouldn't want a restaurant menu with 500 items on it, right?
Definitely menu overload.
You'd be overwhelmed.
Yeah, I'd end up just ordering pizza every time.
Exactly. Interfaces in code are like menus.
Okay.
Keep them small and specific to what each client piece of code needs.
Right.
Don't force them to depend on stuff they'll never use.
Gotcha. Makes sense. Keeps things lean and focused.
Right.
Okay, and finally, we have the dependency inversion principle.
Yes.
The DIP?
Yeah, CIP.
This one sounds pretty intense.
It might be the most important of them all.
Okay.
Think about building a house.
Yeah.
You wouldn't want your electrical wiring directly connected to the power grid, right?
No.
You'd want a circuit breaker in between to control the flow of electricity and prevent overloads.
Good point, yeah. That circuit breaker adds a layer of protection and control.
That's exactly what the DIP does for software. It's about depending on abstractions, not concrete implementations. It's like having that circuit breaker between different parts of your code, allowing them to change independently without causing a system-wide meltdown.
So the DIP is about creating these like buffers between different parts of the code.
That's right.
Allowing them to change and evolve without breaking everything.
Exactly.
That's powerful.
It is, but there's more to building a robust software house than just the solid principles.
Okay.
We also have component principles that guide how we group and structure our code. It's like deciding how many rooms your house needs and how they connect.
Okay, my brain's feeling a little full right now.
Okay.
Maybe we should save those component principles for part 2. Give our listener a chance to digest all this solid goodness.
Sounds good. We've covered a lot of ground, from the history of programming to the importance of adaptability and those solid principles. Take a moment to let that sink in, and we'll pick up with component principles in the next part of our deep dive.
Sounds good.
All right, ready to tackle those component principles.
Yeah.
They build upon that solid foundation we established with the solid principles.
Okay, I'm all ears.
Yeah.
But before we get lost in the blueprints, remind me, why do these component principles even matter? Like, how do they connect to this whole clean architecture idea?
So remember, clean architecture is all about creating software that's easy to change and maintain, right?
Right.
Component principles help us organize our code into well-defined units,
Okay.
making it easier to understand, modify, and reuse different parts of the system.
Okay, that makes sense. It's like having labeled drawers for your tools
Right.
instead of everything jumbled together in one giant toolbox, right?
Yeah, exactly.
So what's the first principle we're looking at?
Let's start with the common reuse principle, or CRP.
Okay.
Think about your kitchen. You probably keep your baking supplies together, flour, sugar, baking powder,
Right.
because they're often used together.
Right. Makes more sense than storing the flour with the cleaning products.
Exactly. The CRP says that classes used together should be packaged together.
Okay.
This helps manage dependencies and ensures that related code lives in the same neighborhood.
So it's about grouping things logically based on how they're used.
Right.
What about the common closure principle, or CCP?
Mm-hmm.
Does that have a kitchen analogy too?
Maybe not a kitchen analogy, but think about packing for a trip.
Okay.
You wouldn't pack your swimsuit and ski gear together, right?
True. Packing for all possibilities would just weigh me down.
Because those items change together.
Yeah.
You'd only need one or the other, depending on your destination.
So the CCP is about grouping things that change together.
You got it. Classes that are modified for the same reason should be bundled together.
Okay.
This minimizes the ripple effect of changes.
Right.
If you need to update something,
Yeah.
you ideally only change code in one place.
Okay. That's starting to click.
Mm-hmm.
So CRP is about how things are USE together.
Yes.
CCP is about how they change together. What comes next?
Next up is the acyclic dependencies principle,
Okay.
or ADP.
ADP.
Imagine a city where the roads only go in circles.
Correct.
You could drive forever and never get anywhere new.
That sounds frustrating. Yeah, I'd be going in circles.
Exactly. The ADP says your code dependencies should never form a cycle. If Module A depends on Module B shouldn't depend back on A.
Okay.
Otherwise, changes can cascade through the system in unpredictable ways.
So it's about avoiding those circular dependencies.
Right.
They can make code so hard to untangle.
Exactly.
What's next on our list of principles?
Now we have the stable dependencies principle, or SDP.
Okay, SDP.
This one's about managing risk. Imagine building a house on a foundation of sand. Not a good idea, right?
Definitely not. I want my house built on solid ground.
That's the idea behind the SDP.
Okay.
You want your more stable, less likely to change components
Right.
to be depended on by less stable components.
Mm.
Your foundation shouldn't rely on something flimsy.
Okay, so it's about dependency direction.
Right.
Pointing towards stability.
Yes.
What's the last component principle we need to cover?
We finish with the stable abstractions principle, or SAP. This one ties back to the open-close principle we discussed earlier. Remember, we want systems that are open to extension, but closed to modification.
Right, like adding new apps to your phone without rewiring the whole thing.
The SAP says that your stable components, the ones less likely to change, should be abstract.
Okay.
This allows them to be extended without requiring major modifications.
Okay, so SAP is about using abstraction to create flexibility and stability at the core of our software house. It's like having a universal power adapter that can work with different types of plugs.
That's a great analogy. And with that, we've covered all the component principles.
Oh.
They work in harmony with the solid principles to create a robust framework for organizing and structuring our code.
Wow, we've thrown a lot of principles at our listener today.
I know, right?
Maybe before we move on, can we do like a quick recap just to make sure all these principles are sinking in?
Absolutely. We started with the common reuse principle,
Yeah.
which is all about grouping things that are USD together. Then we talked about the common closure principle,
Which focuses on grouping things that change together.
Right. Then we had the acyclic dependencies principle,
Yes.
which warns us against creating those circular dependencies that can lead to code spaghetti.
That's right.
Then we talked about the stable dependencies principle, which reminds us to depend in the direction of stability, like building a house on solid ground.
Exactly.
And finally, the stable abstractions principle tells us that stable components should be abstract,
Right.
allowing them to be extended without modification.
You got it.
Phew. Okay, I think I'm starting to see the big picture here.
Yeah.
These principles are all about creating code that's well organized, easy to understand, and resilient to change.
Exactly. They help us lay a strong foundation for building software that can stand the test of time.
Right, but principles are only part of the story.
Yeah.
Uncle Bob also delves into real-world examples through what he calls archaeology stories.
He does. He does.
I've been curious about that. They sound like mini history lessons.
They are, yeah. About software development, what's the first stop on our archaeology tour?
Let's travel back to 1969
Okay.
to a company called ASC, where Uncle Bob got his start.
Okay.
They were building a system for a labor union using a DateNet 30 computer.
Wait, 1969? That's like ancient history.
Yeah.
In the tech world.
It is.
What were they even working with back then? Like slide rules and punch cards?
Pretty much. They used punch cards and magnetic tape
Okay.
and even had to write their own disk drivers.
Jeez.
It was a different world.
Can't even imagine.
Yeah.
But even back then, were they encountering the same problems that we struggle with today?
Absolutely. One of the key takeaways from this story is that even with primitive technology, the need for modularity and decoupling was apparent. They had to rewrite a huge chunk of code when they switched from punch cards to magnetic tape for data storage.
So the need to like separate data access
Yes.
from the rest of the system
That's right.
was a lesson learned early on.
It was.
It's like they were intuitively grasping the need for clean architecture principles without even having the language for it.
Right. And this story highlights how these principles aren't tied to specific technologies. They're about timeless challenges in software development.
Okay.
Ready for the next stop on our historical journey?
Absolutely. Where are we headed next?
Let's fast forward a couple years to 1971.
Okay.
Uncle Bob was hired to work on a shop floor automation project
Okay.
at a company called OMC.
Shop floor automation.
Yeah.
Were they building robots back then?
Not quite robots, but they were using an IBM System 7
Okay.
to control machinery and processes.
Gotcha.
What's fascinating is that even in assembly language, you can see the seeds of architectural thinking.
So even at that low level, they were already thinking about how to structure their code effectively.
They were.
What did they learn from that experience?
One of the key takeaways is that even in assembly language,
Yeah.
you can apply concepts like threading, where multiple tasks share the processor.
Okay.
They were already grappling with the complexities of concurrency and resource management.
Right. Which are still major challenges today.
Yeah, absolutely.
It's amazing to see how these like fundamental challenges have persisted through the decades. It's like software development is a constant conversation
It is.
with complexity.
Yes, that's a great way to put it. It's a reminder that the principles of clean architecture aren't just about specific technologies or languages,
Right.
but about addressing those fundamental challenges that are inherent to software development.
Okay, I'm eager to hear about the next archaeology story.
Yeah.
What's next on our historical tour?
Our next stop is a project called 4TL,
Go.
a system for testing telephone lines. Uncle Bob worked on this project for 12 years, starting in 1976.
12 years on one project. That's a long time. It must have gone through some major changes during that period.
It did. They started with a monolithic design, with all the code lumped together.
Yeah.
Imagine trying to find a specific tool in a giant toolbox with no compartments.
Sounds like a recipe for frustration.
Yeah, for sure. Did they eventually find a better way to organize things?
I hope so.
They did.
Okay.
They started breaking the system down into chips, each responsible for a specific function. It was an early form of component-based architecture.
Okay.
And they even developed a system for plugging in new chips to add functionality, just like we use plugins today.
That's incredible. They were pioneers of modularity.
Yeah.
But even with this like innovative approach,
Yeah.
did they still face challenges?
They did. One of the key lessons from this story is that isolating components and managing dependencies is an ongoing process.
Yeah.
They struggled with code being scattered throughout the system,
Right.
which made changes difficult and error-prone.
It's like even when you have the right tools and ideas,
Yeah,
putting them into practice effectively is still a challenge.
it's true.
What's the next stop on our historical tour? I'm ready for another software time travel adventure.
Let's jump to the early 1980s.
Okay.
When the C programming language was gaining popularity. Uncle Bob was a strong advocate for C, seeing it as a major step up from assembly language.
C is still widely used today.
It is.
So, and it must have been a significant innovation. What did this shift to C teach them about software architecture.
Well, C offered higher-level abstractions and made code more portable,
Right.
which was a huge win.
Right.
However, they still ran into problems, especially with databases.
Hmm.
Uncle Bob tells a story about a project where they went overboard using embedded SQL,
Hmm.
basically mixing SQL commands directly into their C code.
Oh, no. I can see how that would create a tangled mess, right? Like the code and the database become inseparable.
Exactly. It's like writing your grocery list directly on your kitchen counter.
Right.
If you need to rearrange things, you have to rewrite your whole list.
Yeah.
This experience reinforced the idea that databases are details, not core architectural elements.
Okay.
They should be extracted away from the core business logic.
So even with a powerful language like C, they still had to learn the hard way
They did.
about the importance of decoupling and managing dependencies.
Right.
It seems like no matter how much technology evolves,
Yeah.
these fundamental principles
They do.
remain crucial.
You're spot on. And it's a reminder that clean architecture is not about being anti-technology.
Right.
It's about using technology wisely and making sure it doesn't dictate your design decisions.
Okay, ready for our next historical deep dive. Where are we going now?
Let's head to a project called the Electronic Receptionist.
Okay.
This was a really ambitious project that combined computer systems, telecommunications, and voice systems.
Wow, that sounds like they were way ahead of their time. What happened with this project?
They managed to build a working prototype, but it was incredibly complex and messy. It reinforced the lesson that even with new and exciting technologies, you still need to focus on modularity, decoupling, and managing dependencies.
Right.
Those challenges never go away.
It's like no matter how fancy the gadgets get,
Right.
you still need a good organizational system
You do.
to keep everything from falling apart.
Exactly. And this brings us to another important point.
Okay.
Sometimes the best solution is the simplest one. You don't always need to build a complex system
Right.
when a simpler one will do.
Okay, so it's not about over-engineering things just because you can.
That's right.
Sometimes simplicity is the key to maintainability.
Absolutely.
Where does our historical tour take us next?
Let's fast forward to 1988 to a startup called Clear Communications.
Okay.
They were building software to monitor the quality of T1 lines,
Okay.
which were the backbone of the long-distance telephone network at the time.
So this was mission critical software.
It was.
They must have been using the latest and greatest technologies.
They were. They embraced C, UNIX,
Okay.
and graphical user interfaces,
Okay.
all cutting edge at the time.
Yeah.
However, they initially over-engineered the system with a complex 7-layer ISO communications stack.
Wow. Talk about overkill. Did they eventually simplify things?
They did.
Okay.
They learned from their mistakes and adopted a more pragmatic and modular approach. And they also learned a hard lesson about jumping on technology bandwagons.
Okay.
They made the mistake of using an object-oriented database, which turned out to be a dead end.
So it's a reminder to be cautious about new technologies.
It is.
Just because something is trendy doesn't mean it's the right solution
That's right.
for every problem.
And it reinforces the idea that clean architecture is about making informed design decisions that prioritize long-term value over short-term trends.
Okay, I'm seeing a pattern here.
Yeah.
It seems like each of these stories reinforces the importance of sticking to these fundamental principles,
Yeah,
even when, like, embracing these new technologies.
that's right.
What's the next stop on our historical tour?
Let's visit Rational Software,
Okay.
where Uncle Bob worked on Rational Rows, a popular case tool for software modeling.
Right.
This was an environment that really emphasized software design and architecture.
So they were walking the walk. What lessons did they learn about clean architecture in this context?
One of the biggest takeaways was the importance of separating the GUI from the core logic. They tried to create a reusable framework for multiple applications,
Okay.
but it didn't quite work.
Ah.
They learned that you can't always anticipate every use case,
Right.
and that you need to be willing to adapt your design to meet new requirements.
So even with, like, a strong focus on design,
Yeah,
they still had to learn the importance of flexibility and adaptability.
absolutely.
It seems like software development is a constant process
It is.
of learning and refinement.
Absolutely.
Okay, ready for our next historical adventure. What's next on our archaeology tour?
Let's travel back to 1993 to a project involving software for automating student testing.
Bringing technology into education.
Yeah.
What what challenges did they encounter in this project?
This project had its fair share of twists and turns.
Okay.
They faced a tight deadline,
Okay.
changing requirements,
Yeah.
and even had to switch programming languages mid-project.
Oh, wow.
They started with Smalltalk
Okay.
and eventually moved to C++.
Ah, so they were dealing with like the classic challenges of like time pressure,
Mm-hmm.
shifting needs,
Right.
evolving technologies.
Exactly.
It sounds like a real-world test of their architectural principles.
It was. They also had to manage a large and distributed team,
Oh,
which added another layer of complexity.
right. Okay.
They learned the importance of clear communication, collaboration, and building a solid foundation that could be adapted and extended as needed.
So they were putting those principles into practice
They were
under like real-world constraints.
real-world constraints, exactly.
What's the next stop on our historical tour?
Let's visit Teradyne,
Okay.
where Uncle Bob worked on a system for testing electronic circuit boards.
Okay.
This was a highly complex system that involved custom hardware, software, and firmware.
Wow, that sounds intense. What did they learn about software architecture in this like challenging environment?
One of the key takeaways was the importance of separating concerns.
Okay.
They had different teams working on different parts of the system,
Yeah.
and they needed to ensure that changes in one part didn't ripple through and break other parts.
So it's back to the importance of modularity and decoupling.
Exactly.
How did they achieve this separation of concerns in such a complex system?
They used a combination of layering, encapsulation, and clear interfaces between modules.
Ugh.
They also had a strong emphasis on testing to make sure everything worked as expected.
Hmm.
They were applying many of the principles of clean architecture, even if they didn't use that term at the time.
It's fascinating to see how these like principles emerge organically from like real-world challenges.
It is.
Even before they're like formally defined.
It highlights the fact that these principles are not just theoretical concepts,
Right.
but practical solutions to real-world problems.
Mm.
They've been proven effective time and time again.
Okay, ready for our next historical deep dive? Where are we headed now?
Let's travel back to the days of VHS tapes
Yeah.
and visit a project for a video rental company. Remember those?
A blast from the past.
Right.
I used to spend hours browsing the aisles
know.
at the video store. What challenges did they encounter building software for a video rental business?
This project was interesting because it involved integrating with lots of external systems and data sources, inventory systems, customer databases,
Yeah.
payment processors.
Wow.
They had to figure out how to connect all these different pieces reliably and securely.
So they were dealing with the complexities of like integrating different systems, which is still a major challenge today.
It is.
Right.
They had to find ways to abstract away those external dependencies
Okay.
and keep the core business logic as clean and independent as possible. This is where the dependency rule really shines.
It makes sense. You want to isolate your core logic from like the unpredictable nature of those
Right.
external systems.
Right.
It's like having a buffer zone to protect yourself from sudden changes.
That's a great way to think about it.
Hmm.
Ready for one more archaeology story before we wrap up this part of our deep dive?
Absolutely. Bring on the historical software wisdom.
Our final stop takes us to a financial services company
Okay.
where Uncle Bob worked on a system for managing investment portfolios. This was a high-stakes environment with strict regulatory requirements
Right.
and a very low tolerance for errors.
So the pressure was on. What lessons did they learn about software architecture in this like demanding context?
They learned that building auditable and transparent systems is crucial in such environments. They had to be able to track every decision and transaction and explain their reasoning to regulators.
Right.
They couldn't afford to have a black box system that nobody understood.
So it wasn't just about making the software work.
Right.
It was about making it understandable
Understandable, yeah.
and accountable.
Accountable, absolutely.
How did they achieve that level of transparency?
They focused on clear boundaries, well-defined responsibilities, and thorough documentation and testing.
So
They applied the principles of clean architecture to ensure the reliability, integrity, and auditability of the system.
it's a powerful reminder that these principles aren't just about like technical excellence.
Yeah.
They're also about like business value,
Yes.
risk management, ethical consideration.
Absolutely.
Wow, these archaeology stories have been Fascinating.
Yeah.
It's amazing to see how these principles have been applied in so many different contexts and how they've helped teams overcome challenges and build successful systems.
Yeah, they offer valuable lessons that are just as relevant today that
Right.
they were decades ago.
But enough about the past. Are you ready to bring clean architecture into the present?
I
All
am.
right. Let's see how these timeless principles apply to like the modern world
Yes.
of like mobile apps,
Right.
cloud computing,
Mm-hmm.
all the exciting technologies that are shaping the future of software development.
Let's do it.
On to part 3.
All right, we've time traveled through software history with those archaeology stories.
Right.
But now let's bring clean architecture into the modern age.
Okay.
First up, mobile apps.
Yeah.
They're everywhere, but building a good one is tough.
Mm-hmm.
How does clean architecture help with those unique challenges?
You'd think all this architecture stuff is overkill for a tiny app,
Right.
but it's actually the opposite.
Mm.
Mobile apps have to be lean, responsive, and handle spotty internet like a champ.
Clean architecture gives you that solid foundation to build upon.
Okay, walk me through it. If I'm building a mobile app,
Okay.
where do I even start
Right.
with clean architecture?
Same principles,
Yeah.
different playground. You still want to figure out the core of your app,
Right.
what makes it unique. Those become your entities and use cases, the heart of your app.
Okay.
Then think about those pesky details like the user interface and network calls.
Yeah.
Those get pushed to the outer layers with interface adapters acting like bouncers, controlling what gets in and out.
So it's like creating a VIP area
It is.
for the essential logic, keeping it safe from the chaos of the outside world.
Exactly. And when you think about things like syncing data when the phone is offline,
Right.
you'd handle that in the outer layers
Okay.
using patterns like repositories. They act as intermediaries.
Okay.
So your core logic doesn't care if the data comes from the internet or the phone's storage.
Wow, that's clever.
Right.
It's like having a personal assistant who handles all the logistics so you can just focus on the important stuff.
Exactly.
So clean architecture isn't just for big, complex systems.
No, it's not.
It makes sense even at the app level.
It scales beautifully, and it's not just mobile either.
Okay.
The cloud is another area where these principles shine.
Oh, the cloud. It feels like everything is moving there these days.
It does.
How does clean architecture handle the complexities of cloud environments with all those distributed systems and microservices?
The cloud brings new challenges, right?
Yeah.
Distributed systems, microservices, serverless functions. It's a whole different ballgame, but guess what?
Yeah.
The core principles still apply.
Wait, really? How does the dependency rule work when your app is spread across like a bunch of different services?
Think of it like building a city instead of a single house.
Okay.
Each microservice is like a building with its own purpose and structure.
Hmm.
They need clear boundaries and well-defined ways to communicate with each other.
Right.
Otherwise, you end up with chaos.
Okay. Yeah. I can see that. A city needs good infrastructure
Mm-hmm.
to function.
To function, yeah.
What about those serverless functions?
Yeah,
Those seem super trendy right now.
they are.
How do they fit into the clean architecture picture?
Serverless functions are like little bursts of code that do one specific job,
Okay.
like processing a payment
Right.
or resizing an image.
Yeah.
You can apply clean architecture principles to those individual functions to keep them focused, testable, and easy to maintain.
So even in the cloud, with all these new technologies,
Yes,
the fundamentals
Yeah.
still matter.
they do.
It's not about blindly adopting the latest trend.
Right.
It's about applying these principles
Mhm.
to create systems that are robust, adaptable,
Right.
and ultimately more valuable.
That's the essence of it. Clean architecture helps us manage complexity no matter what technologies we're using or what challenges we're facing.
Right.
It's a timeless approach to building better software.
Yeah, this whole deep dive has been a real eye-opener for me.
Yeah.
We've gone from like punch cards and assembly language
Right.
to mobile apps and the cloud.
Mm-hmm.
And through it all, these core principles have remained relevant.
They have.
I feel like I have a much better understanding of what it means to build software that can truly stand the test of time.
Me too. And it's not just about the technical aspects.
Right.
Clean architecture forces us to think about the human side of software development. It's about building systems that are easy for people to understand, maintain, and adapt.
Right.
It's about creating software that serves people, not the other way around.
That's a fantastic point.
Yeah.
It's a reminder that software development is ultimately a human endeavor. We're not just building machines.
Right.
We're building tools that can empower people, solve problems,
Yes.
and make the world a better place.
Well said. And that's what makes clean architecture so compelling. It's not just about writing code, it's about building a better future through software.
I couldn't agree more. So for all our listeners out there, I encourage you to uh, dig into clean architecture, explore these principles, and experiment with applying them in your own work.
Yes.
It might just change the way you think about building software.
It might.
That's a perfect note to end on.
Yeah.
Thanks for joining us on this deep dive into clean architecture.
It's been fun.
Until next time, keep your code clean, your minds open, and your passion for building great software burning bright.